about the ice, we're studying water. So within our mission right away, in the first couple of months of being on the surface, we were able to determine that the robotic arm could scrape through the surface soils only a few inches deep and reveal an ice layer. This is really important. And now our mission is about studying the history of this ice and soil that are within reach of the robotic arm, and to determine if this is a place on Mars that is habitable. Could Martian life live in this environment? And of course, we're somewhat biased when we talk about Martian life because we only know life as it exists on the Earth. And so that's kind of the idea we have, is to see if this is an environment that Earth microbes could live in. And we're also studying the climate because we recognize that the ice at the surface is in close contact with the atmosphere. And as Jim has just pointed out, there is definitely a very close connection between ice under the surface and water vapor and ice crystals in the atmosphere. Let's take a look at our landscape in one of our latest panoramas. And this is the spacecraft in the foreground. And we'll take a little scan around to see just what this environment looks like. You see the solar panel in the middle of the frame there, and a mast sticking up that holds our temperature sensors and a little telltale by which we measure winds. There's a lot of things to see here. In particular, the ground is not flat like a parking lot, but it's kind of bumpy. And these bumps are typically 1 or 2 meters across, 3 to 6 feet across, and they're formed by the expansion and contraction of the ice. At least that's how it would be in the polar regions of the Earth. We have dug in the centers of the polygons and find that the ice layer is about 2 inches below the surface, and we've dug in the troughs and find it's as much as 3 to 5 times deeper in the troughs. So if you were to sweep away this thin soil layer on this what looks like a flat plane, you would find that it's really more like a skating rink. It's a very ice-rich environment. There's some things you don't see in these pictures, and that is large rocks, and you don't see dunes. So clearly, there hasn't been a lot of material brought in by the winds to form dune fields and things of that nature. Nearby our landing site is a large crater, and we are actually on the material that was blown out of the crater when it was impacted some millions of years ago. And this is important. It's only a few million years ago that that crater was formed. It's a very new crater on Mars. It's not, the terrain we're on is not the thousands of millions of years old that is being explored by the 2 rovers, for instance. So we're looking at modern processes that are active on Mars today. This is a new environment that we're looking at, not an ancient environment. So what are the facts that we have on the table now after 3 months or 4 months of exploration of this landing site? We know that there's snow coming down from the sky. We see frost on the surface. We measure water vapor in the atmosphere. The atmosphere is a transport mechanism for water, ice, and for vapor. The vapor can actually permeate and diffuse through the soils and freeze out at the ice layer. And we know that the ice is just near the surface. We also know, as was just pointed out today, that we have calcium carbonate, which on the Earth would typically be in the form of limestone, and we have clay. These are indicators of a liquid water past. We know that it's an alkaline soil with a small sprinkling of salts, similar to the salts on Earth, and that there's a component of perchlorate. The perchlorate is actually a very interesting compound, and I'll get back to that. And we also know one other thing that we didn't learn ourselves, but have been studied by scientists over the last 20 years, and that is that the spin axis of Mars is not stable like on the Earth. It's now at 25.5 degrees, but over a few millions of years of time, it actually clocks back and forth, and at some points, it's actually pointed almost towards the sun. It can be tilted over at 60, 70 degrees tilt, and putting the polar region in a position where it's going to have a much warmer climate. So in the past, there's been a warmer climate. So how do we interpret all these facts? In this cold climate now, we don't expect that ice can melt into liquid water, at least unless it has a tremendous amount of salts in it. And so we don't expect to see liquid water at this time. But in the past, when the tilt was more and the climate warmer, we could have expected that this ice goes through a melt phase. And it doesn't mean it's a lake. It could just wet the soil a little bit. And is it that wetting of the soil that has created these carbonates and these clays that are now indicators of a past climate? And the nutrients that we see in the forms of salt and the perchlorate, which on the Earth is a nutrient and a energy source for microbes. Is this a habitable zone on Mars? Well, I think we're approaching that hypothesis. We understand, though, that Mars has many surprises for us, and we have not finished our investigation. We have not finished our laboratory analysis or our data analysis, and so it's too soon to be sure of this. But we're certainly finding a lot of the indicators that we proposed to find early in the beginning of this mission, which is, to me, a great excitement. I mean, we never knew exactly what we'd find down here, and now we're finding indicators of a wetter climate and a nutrient-rich soil. But we haven't finished our investigation. We are not able to claim that we have found organics. We haven't looked at the key isotopic signatures of water that will tell us more about the history of the ice and compared it to the water vapor in the atmosphere. So this picture is still a little blurry. We're making good progress, but more lab work, more analysis is needed. And this is what we're going to be doing on our extended mission. And October is a very busy month for us so that we can complete our sampling and our analysis. And one other thing I'd like to leave you with is that we're also going to try something new in the last few weeks of our power-rich period of our mission. And that is, we brought a microphone with us